you doing?
Chilling.
Chilling? Like a villain?
Yes, ma'am.
That's me with my Loki coat. All right, I have, ladies and gentlemen, I have a 20-minute lecture presentation. It'll go really quick. I would greatly appreciate all eyes up here focused on what we're doing and the conversation about what we've got going up on the board, okay? All right, as you can see, I've only got writing utensils up here, so we're not going to do any big, major, serious drawings or constructions. Bless you.
Thank you.
Though if you would like to have a straight edge in order to draw the 2 triangles we're going to have on today's notes, you're more than welcome to. You don't have to have them. I'm totally not going to use it. You're going to get to see me YOLO my triangles, and they're going to be all over the place. All right, so here we go. Today's lecture presentation is titled Equiangular and Right Triangles. And the topic, the objective that we have today is I will solve problems using the triangle angle sum theorem, that's the one from yesterday, to discover 2 corollaries about equiangular and right triangles. And if you're anything like me, you're sitting there looking at that objective going, what on earth is a corollary? Right? Are you thinking that too?
No.
No? You know what a corollary is?
No, I just was thinking that.
You just weren't thinking that. You were like, blah, wah, 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 wah. Okay. Well, let's tell you what the word corollary is, so the next time you hear it, it won't be a wah, wah, wah moment, but it'll be like, dude, I know that word because I am smart. Okay? So the definition that I have for corollary for you says this. A corollary is a proposition that follows, that's supposed to be an O, that follows from one already proven. Shh. Ladies, thank you. Ladies. Ladies. Later, please. Thank you, thank you, thank you. I have to admit something to you. As I was preparing the lecture notes for today, and I was looking through them, and I read this definition, and I went, what's a proposition?
Really?
Really? Seriously? And I made that face, I went, and kind of pouted a little bit because I felt really dumb. Like I should totally know this word, and I totally didn't.
Is that like a saying? Someone probably like make a proposition to you.
Yeah, and that's exactly how you would use it. But I don't really know what that means other than I've made a proposition to you, and that kind of feels weird in this case. Like, how does that help me know what a corollary is, right? So what I'd like you guys to do is this. Please, 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 if you're into the color, use a different color pen and underline the word corollary. If you're not into different colors, just underline it. And then over here on the left, put an exclamation mark. If you're using colors, please make it the same color as your underline. Now, if you're using colors, use a different color. If you're not, then maybe a squiggly underline. I'd like you to underline the word proposition. And let's put a question mark over it. And I'd love for you to use this tactic anytime. You're reading or taking notes on something and you encounter a word that you look at and go, wah, 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 okay? Underline it, put a question mark over it. And then over here on the left side, next to that exclamation part, put another question mark, same color. And we're going to write the word that confused us. In this case, proposition. And then you got to go ask someone to explain what that word means. I went to Google. And I asked Google what the word meant. And this is the answer that Google gave me that helped this word make sense to me in how it's being used. So Google said that this word means that a proposition is a statement that expresses a judgment, that was me running out of room on my paper, or an opinion. All right. So a corollary is some statement that expresses a judgment or opinion that follows, that comes immediately after some other statement or judgment or something that we have already proven to be true. Okay, pretty cool. So take your pencil or your pen or a highlighter or a marker or whatever and draw a big line. Go from one edge of the page straight across the other. We're completely done with that section, but it's going to relate to what's coming up later. It's just not like a direct, it's not a direct corollary, to use our big word. Okay. I need to do a recall moment with you guys. Okay? A recall moment is just something that we've already talked about, and I want to bring it back up again. And the thing I want to recall for you is the triangle angle sum theorem. That was the theorem we had yesterday. And the way it was written yesterday, it kind of was a little confusing, wasn't it? Like I had to stop and draw a picture, and it was kind of weird. And, so I want to take the weird and get rid of it and give you just like the heart of it. Like this is all you really need to know about it, since it's a recall. It's not the first time you're touching it. You don't have to have the big explanation. You just have to have a quick memory of it, okay? And so the real quick memory I want you to have about the triangle angle sum theorem is this. The angles in a triangle add up, oh goodness, add up to 180 degrees. That's it. That's all you really need to know about the triangle angle sum theorem. Since this is a recall and it's kind of important, I'd like you to take a highlighter, please, if you have one, and highlight it. I'll toss one at you. Hang on. Oh, good catch. It was a bad throw. And then you see the left-hand side, the very, very left, where we've got the exclamation mark from the other things? I'd like you to put the little highlight, just a little blob. Because I'd like to invent a symbol to help you realize when there's some information in there that's a recall bit of information. Okay? And you'll know it when a teacher is talking about it, because in lecture they'll say something like, and if you recall from yesterday, class, right? Or they'll go, who remembers last week when we said, do you have the teachers that do that? Yeah. From here in this class, it kind of comes in the form of, from the video notes, we should have seen. That's a recall moment. That's something that the main information that explains it in detail is found in something that should have come before this moment. Okay? And I need a quick symbol so that you can draw it each time you come across one of those recall moments. What kind? It should be a quick symbol. What kind of symbol do you think you would like?
Cupcake.
A cupcake? Okay. But how long does it take you to draw a cupcake?
Real quick.
Real quick? Okay, use a cupcake for you then.
How about like a bullet?
A bullet?
Like
She's got like the recycle symbol. Like a circle with some arrows in it. That's a good one, like the recycle, because it's coming back around. And you were thinking like a bullet point, like a dot? That totally works too.
How creative.
That totally works too.
What about a stick?
Or a stick, okay, or a back arrow. I had another class do a lightning bolt.
That's done.
I had another class do a light bulb. It wasn't a moment for them. I really like this idea of the circle
What about
arrow
Spider-Man?
kind of recycle thing. Okay? So I'm going to use that for our notes when I'm doing them up
a
here.
recycle?
The recycle symbol, because we're recycling the idea. You guys use whatever symbol you really love. Okay? One that will help you know that this is a moment in which we are recalling, returning, recycling information. So here's
Reuse.
reduce, reuse. reduce how hard it is to think, reuse the information. Hi. All right. So now that we've got this important information recalled, recycled, returned to us, we're going to start something new, and that something new is important. I do.
Okay, and I think you have another one in here.
Okay.
Let me see, her or him?
Yes, I do.
Okay, let me see if you have any more.
Okay, thank you. This item that is the new important thing is called the equiangular triangle corollary. Give me just a moment to sort out, sign whatever she needs me to sign.
No, ma'am, I need work for these students.
Okay.
So you can
I'll
send it to them or,
I will email to DAP.
okay, thank you.
Thank you. All right, back with you. If you're using your own sheet of notebook paper, this kind of first line that's on you, I want you to leave blank. We're going to come back in and fill it in later with the formal, how this is formally written, make it look all fancy. So down here, we're going to do a setup. If I have a triangle, we're going to name it triangle ABC. And we're told that this triangle is equiangular. Whoops, I forgot it's an equiangular triangle. Then we have to go figure out what happens. We've got to figure it out. Let's start by drawing the triangle. This is the moment where if you want it to be super neat, you totally grab your ruler and you make your triangle super neat. Or you can be like how I feel today. I'm totally just going to like whatever on the triangle. Okay, ready?
Same.
Oh. That's what happens when I YOLO my triangle.
Are these like if then?
Yeah, these are kind of like an if-then statement, conditional statement. You're right, yeah. All right. Proof one, why Ms. Carranza needs to use a ruler every time she draws a shape. That's an embarrassing triangle. Okay, well, we have a triangle, and our if statement says if it is equiangular. So we're going to start with an equiangular triangle. It means each one of these angles are congruent to each other. And since this is a corollary, and the thing that we did immediately before talking about this was recall the triangle angle sum theorem, clearly we can use that to help us make sense of this. If the triangle angle sum theorem says we add up all the angles and it gives us 180 degrees, then if we add up these three angles, all of which are the same, that should give us 180. What do each of these need to be in order for that to be 180? They're all the same. What number do you add to itself 3 times to get 180 degrees?
60.
How'd you do that?
With my head.
What'd you do? You divide?
No, I added.
You added.
Yeah.
You added 60, 60, 60. Six,
To get 180, right?
right?
120 then plus
I
60.
did 6 times 3 and then put a 0.
He did 6 times 3 and then put a 0, and you said divide. So you did, what'd you do?
Oh, never mind.
No, you're totally right. Tell me what you did.
You just divide. I don't know. I know you divide.
You divide.
Yeah.
You divided something and it gave you 60. Awesome. Let me show you the detail behind it. We'll put in a little bit of algebra. It's going to be really tiny to hopefully help you see how this gets added together. Okay? So we have an angle we don't know. We assume it's 60. We suspect it's 60, but we're not really sure. So we're going to use our go-to variable of whenever we have to represent a number that we don't know its value. So we're going to use x. And they're all the same, so they're all x's. The triangle angle sum theorem says, hey, dude, add them all together and equal it to 180. So this angle plus this other angle, and that needs to equal 180. And that was from the triangle angle sum theorem. Notice that I've used a symbol there in my reason statement. I can totally do that because it's a 2-column proof kind of thing I'm writing. If I ask for a paragraph proof, make it like an essay. Write the whole word out, okay? Okay. I'm looking for like terms I can combine because now it looks like an algebra thing. Look, I have 3 x's sitting here. My 3 x's come together, they talk bad about me, and I have 3 x's. Oh, that's right, I'm sorry. I forgot, forgive me. Thank you. Need to get rid of that multiplication of 3, yeah? There's your division. Divide both sides by the thing I want to get rid of, which is the 3, and I get left with x equals 60. Please notice that I left the reason side blank. I'm going to give you 10 seconds right now in order to, in your own words, write what we did here so that you will remember. Go. Fantastic. Thank you. Take the same pen or highlighter that you used up here to do this big divider bar and do another divider bar, but don't go from edge to edge. Just go from that left margin to the edge of the paper. We're doing a small division. It's related to this stuff, but it's different from the equiangular triangle corollary. So we want to make it a little different, but still show that it's part of the same thing. All right. This last big major idea is also important. And the name of this important thing is the right triangle corollary. Oh, I forgot the formal language. Didn't I? Right here. Right here, up here. Can I go back up to the equiangular triangle for a second? I'm very sorry. Thank you. I'm very, very sorry. I'm going to write it in a different color just so that it stands out and it looks kind of pretty. Okay. So here's the formal language. You want me to write it in super pretty cursive for you? Yes? Okay. So it says, hang on, I need my cheat notes because I want to make sure I get the right formal language. Okay, it says, oh my goodness, cursive is hard. The angles in an equiangular triangle are each 60 degrees. Phew. It's been a long time since I wrote full cursive like that. Thank you for making me practice. Got it? Okay. Okay, we're going to do the same thing for the right triangle corollary. If I have some triangle, we'll call it ABC, and that triangle is a right triangle, then something else is going to happen. We got to go figure that out.
Each one is 60?
Yes, 60 degrees. So let's draw a right triangle. Again, this can be a moment where if you want to make it beautiful and look nice, you can use a ruler. I'm totally not going to do it because I don't feel like it today. And I'm just going to, there. Oh, hey, that one came out nice. All right, go me. I'm going to label it. There we go. Now, our triangle angle sum theorem says that we can take all the measures of those angles and add them up, right? So let's do it. I'm not going to use variables this time. I'm going to use the wording measure of angle A plus the measure of angle B plus the measure of angle C. All of that equals 180. And our reason, again, is that triangle angle sum theorem.
Oops.
It's okay, you did good. You did good. But I know one of the angles of these triangle already, don't I? I know the measure of one of them. Which one?
C.
C. I already know that C is 90 degrees, so I can totally make that replacement. And no one will yell at me for it. And I will be happy because I like to spend my life avoiding being yelled at if at all possible. Don't you? Just avoid being yelled at. Just try not to be yelled at. That's what I do. Okay. I am going to, look at this, I've got a number here and a number here. Stuff I don't know. So you know what, I'm going to put all the numbers together just because it just looks neater with all the numbers on one side and stuff on the other. So I have 90 over here, and then the measure of angle B plus the measure of angle A over here. And that's really about as far as I can go until I'm told some information about the measures of A and B. But this gives me something pretty important to begin with. Do you remember? Recall moment. Do you remember what we call angles that when you add up their measures give you 90 degrees? The right angles are definitely the 90 degrees. These ones aren't right angles because they're not 90 degrees themselves. But you add them and get 90. Do you remember what those were called? Here's a recall moment. Shall I give you the name?
Give us a hint.
Give you a hint. Say it. Complementary. There it is.
Oh, Jared, go on to guess.
Someone dragged it out of the back of their mind. Yes? Nicely done, sir. And there's your other recall moment. They are complementary. Beautiful. Let's do that formal language real quick. And then I want to do one little example, and we're completely done. Right? Touchdown. Okay, so here's the formal language. I don't know how to do a cursive capital T. I've never figured that out. The acute angles of a right triangle are complementary. Phew. There it is. Let's do our quick example, and then we'll be done. Okay, so I'm going to say that this angle is 5x plus 3 degrees, and I want this angle to be 4x minus 3 degrees. It's an example, so I'm literally just making up numbers. Okay, so don't hate me for making up numbers. Because I love you guys, I'm making up numbers. Okay. Now, originally, the triangle angle sum theorem would have us adding this plus this plus this and getting 180, and then we'd have to solve the whole thing, and we'd have this extra number to deal with, and now we have a shortcut. We don't have to set it equal to 180. We can just grab these two, add them together, and set them equal to 90 because they are complementary. Do you see it? Totally just used a shortcut. Now we're going to go ahead and solve these guys for x. This thing plus this thing. Those are like terms. Hey, here's some like terms too, the numbers. Positive 3 with a negative 3.
0.
Yeah, 0. They kind of cancel and go away. So that equals 90. Now what?
Divide both by 9, you get 10.
divide both sides by 9 to get rid of that multiplication of 9, and x now equals 10. What if the question was, give me the measure of angle A? Then, yeah, I don't know. What do we do? All right.
We'd give them the measurement.
Yeah, we're going to give them the measure of A, so we got to go figure it out. The measure of A is represented by this expression, 5x plus 3, but I totally know the value of x. So I can totally do this substitution, and I get 53. What if I were asked, hey, give me the measure of B, what could I do?
Do the same thing.
Yeah, I could totally do the same thing. Or, I have an option here. I could do 90 minus the measure of angle A. And these two, perfectly legitimate. They mean the same thing. Okay? That's all I got.